Okay, so here we're going to focus on conditional probability. Events have probabilities that can change depending on what happened beforehand. Sometimes one event happening affects another one happening. If this is the case, these are dependent probabilities. At least that's what you would have called it at GCSE. And a good example of this from GCSE is from when you had tree diagrams. So here's a typical question. There were 4 green buttons, 7 blue buttons. We pick one at random and we do not replace it. And then we try and pick a second one. The probability that I pick green on my second attempt is different depending whether or not I picked green the first time round, depending on what happened the first time round. So if I pick green the first time round, a green on the second draw is 3 out of 10. If I do not pick green the first time round, a green on the second draw is 4 out of 10. So this was a dependent tree diagram, or a tree diagram without replacement. In A-level, we're going to refer to this as conditional probability. Using what we know about conditional probability would be a good way to model these events. Here's some new notation. This vertical bar is read as given that. So the phrase given that. This statement says the probability of A occurring given that B has occurred. Similarly, this statement is the probability of A occurring given that B has not occurred. We've previously looked at independent events. These are events that are not affected by another event happening. Our original test of independence showed that 2 events could be proven independent if the probability of A multiplied by the probability of B equaled the intersection of A and B. Well, now similarly, we can test for independence if any of these statements hold true. If the probability of A given B is equivalent to the probability of A given not B, or just to the probability of A, then that proves that A and B are independent. We're going to go ahead and look at how to solve some problems involving conditional probability. And what I want you to focus on, or the concept I want you to understand, is that we're reducing the scope of our initial interest. Instead of being interested in the entire set, we're now interested in a smaller subset. If we're finding the probability of A given B, I've reduced my initial interest to just set B. Okay, let's have a look. So here we're given some data and we're told to make a 2-way table. We know the grand total of students is 75. 25 of them study only humanities. 37 study only science subjects. And we know that 11 students study both science and humanities subjects. If we start with those 4 values in a 2-way table, we can then fill in the blanks. Looking at this 2-way table, we can be asked some set notation probability questions. So the first one, the probability that a student picked at random does not study a science subject and does not study a humanities subject. So there are only 2 of these students out of the 75 students we were interested in. 2 out of 75. The next question, it has that given symbol, that vertical bar. That's how we know that this is a conditional probability question. We need to find the probability that somebody studies a science subject given that they study a humanities subject. So I'm going to reduce my initial interest just down to the students who study humanities subjects. The highlighted yellow portion is all I'm interested in. So the total number of students represented here is 36 students. So now, what is the probability that somebody picked from these studies a science subject? It's going to be 11 out of 36. I've reduced my scope of initial interest. The way I would read this probability statement, I'm going to use this phrase that I've got on the screen. The probability somebody studies a science subject if I'm initially interested in only the people who study a humanities subject. 11 out of 36. The next question, the probability that somebody studies a humanities subject given that they do not study a science subject. The probability of H given S dash. The probability of H given not S. So, my initial interest is for the students who do not study a science subject. These are the highlighted students. In total, there are 27 of them. I'm initially only interested in these 27 students. So going back to answer the question, the probability somebody studies humanities if I'm initially interested in only the students who do not study a science subject. So it's going to be 25 out of these 27. Okay, so conditional probability, we're reducing the scope of our initial interest. We're not thinking about the whole group anymore, but we're highlighting a subgroup. We're using the given statement to identify the subgroup, the subset that we're initially interested in. Okay, let's just try one more before you get into it. If we're told that two four-sided dice are thrown together and the sum of the numbers shown is recorded, given that at least one dice lands on a 3, find the probability that the sum of the two dice is exactly 5. So this is given in words without the symbols, but I'm still trying to understand or to identify the conditional part, the given part. Given that at least one dice lands on a 3, well, that means I'm initially interested in only the outcomes where one of the dice was a 3. That'll be these outcomes for dice number 2 and these outcomes for dice number 1. In total, there are 7 outcomes here that we're interested in. Out of those 7, how many lead to a score, a sum of exactly 5? Only 2 of those 7 are a sum of 5. So the probability that I get a sum of 5, given that at least one of the dice lands on a 3, will be 2 out of 7. Okay, just to quickly respond to the modeling assumption, I have made the assumption that these are fair dice. The question didn't mention it, but I've made the assumption and I've worked on the basis that both of these four-sided dice are actually fair dice. Okay, so for conditional probability, I'd like you to reduce the scope of your initial interest. Highlight or identify the values that you're initially interested in, and then calculate your probability. So you will likely be asked to produce a diagram to start the question, and a good diagram will help to lead to a sensible and correct solution.